So we talked about, I mean, how obviously everything is software. Things will every customer has a unique environment. There are issues that will crop up, and so support actually from our perspective and from a strategy perspective plays an important role, right? So we have seen EMC, NetApp, Nimble use this to their advantage, and I think we completely believe in that story. And again, I think when you're talking petabytes of storage, you want machines and algorithms to start looking for anomalies rather than manually going and looking for just alerts and things like that, right? So what we did was, I think it's just a slide around. I call it reactive support versus proactive support, right? Where rather than a customer picking up a phone call and calling me when an issue happens, I want to go to a mode where Rajesh here from the support team detects a problem, picks up a phone and calls the customer, right? Completely opposite mechanism, right? So and the idea here is, let's keep that support window as short as possible. Let's find out what the problem is, and let's offer recommendations as to what needs to be done, right? So I'll give you some examples of how this is proving out to be a pretty good thing. At a high level, I think it's a standard architecture. You have telemetrics and sensors built into our system. We have a lot of sensors for our own software, and we have sensors for the hardware, again from a software perspective. And then we have a cluster that actually runs in our data center, which collects all of this information. We eat our own dog food, so it's actually running on an Hyperstore S3. So all the telemetrics come in as objects, as puts. So there we'll store all of them. And then we have Spark and different tools here that basically analyze all that data. Okay. So here is just a screenshot of what it looks like. We collect all this data. They all come down as a configuration file, right? All these sensors are an XML data. We basically take these objects and run queries on them, right? What kind of information are we monitoring? We are monitoring processes, disk usage, Cassandra data, telemetrics, the load pattern, the disimbalance, shortage, various kinds of data. And this is again are built on a daily basis, right? So once we have the sensor data, and once we pull it all together, I can write algorithms at a much faster pace because it's completely driven from a cloud perspective. Here is an example, when a customer calls, or when Rajesh, maybe we should come here. He's actually one of our senior developer guy in the support team, right? So our support team is not considered as, again, your standard support. They are extension of engineering, where they're also starting to understand the code, understand how to write these smarter algorithms. So here's an example when this customer calls us, or when there is an alert that has been picked up. We already know the whole configuration of the system. We already know what policies they have, what kind of load the system is generating, and we can literally look at it from a single click, right? So we are not waiting for the customer to provide us, okay, where's the configuration, what's all that information. Again, get into the the issue. Here is actually a real customer, I think 2 quarters ago, and they had a rogue application which actually started to pump data. It was a backup application. I won't name the vendor, but it was supposed to expire some data, and and they had a bug, and they were not expiring it. So they actually started, and literally within in a few days and weeks, they were literally at 90% capacity. And obviously, one of the things that we have written is to identify patterns and anomalies, and the algorithm actually picked up that they are actually running at a really fast pace, and they're about to hit the 100% capacity. So we actually picked up the phone, called them, and they were able to identify, because they thought that the backup application is expiring data, and he's only supposed to keep few terabytes of data. And again, so he was able to catch that, catch the backup admin, make sure you're not running out of capacity, because obviously once you're full, then you have your backups are not going to continue anymore, right? And what it came, and I think the second piece was, again, as we not just only identify patterns, but we also look for recommendations that we give, right? So Rajesh here literally had done an analysis which actually told them that their policies were a little bit out of whack. That means you may actually have created a data center where one was only where, let's say, 100 terabytes, the other one was, let's say, 400 terabytes. And if you have not written the policies correctly, you may be actually pushing data to the wrong data center as opposed to the right data center, right? Here is another example where Smart Support automatically actually picked up that there are certain drives that became hotspot, and they were literally about to go full. So the system will automatically take the corrective action. But I think at that point we need to look at what was happening. Maybe the key space was becoming hot, or some other condition that was happening, right? Here is another example. So as I mentioned, as part of the telemetrics, we also collect the amount of load that the system is generating. So for example, if there was an issue, we actually know exactly at any given point in time what was going on in the system. Was it the gets, the puts, or how much was the load, right? I think the point here is that with this wealth of information, we are able to help the customer much more effectively, rather than just scanning through the logs and things like that, right?
So are you proactively reaching out to the customers, or is this based on when they call in and are asking something?
No, this is proactive, right? So so these algorithms, they run on a daily basis. It's using Spark and various different algorithms, and as they detect these anomalies, actually we automatically create a case. It actually goes up in the Salesforce. They get an email, and depending on the severity, it automatically they jump on it, and they start looking into it, right? So the customer has no idea yet. Maybe he's gotten the alerts from the system, but if he's not looking at it, there is somebody else who is already working on it. And if it becomes, let's say, for example, if there is a critical issue, we pick up the phone and we call him, saying we have detected this, and then the customer can start looking into it. And and if there are best practices or remediations that are needed, we obviously help them do it, right? So we are not waiting for him to call us, right? I mean, that's the whole point of smart support, right? And obviously this is all we need permissions from the customer. If the customer is super paranoid about it, they can decide what to turn off. And the key here is we are not collecting any customer sensitive data. This is all about the configurations of the system. It's about our system, right? So we're not collecting their data and pushing it out to us. Right?
So you're doing all analysis in your own data center, obviously.
Correct.
Mm-hmm. So how often are you looking to improve and to add to those features?
So I think from a product strategy perspective, smart support is an independent a product that we have internally. We have a team of engineers who are literally building algorithms on a daily basis on top of Spark and things like that.
And are they going back and reanalyzing data that's already been collected to see whether there's something that was missed that could have been highlighted as a possible?
So I don't know if we go in the past, but Rajesh.
Because
Here.
Because we have the past data as one of the slides that showed up. It had the past data for the past, when the customer started has the installation. From day one, we have all the data. So we could run analytics, pick a date, pick a range, then do the analytics. And what we were showing here is what happened to the cluster at that specific time in terms of how many S3 ports, how many S3 complete multi-part uploads were happening over the past hour. So we could drill down to that sort of detailed analytics.
And how long are you keeping the data for? So
we are having the data forever, but then we are running analytics just on the previous day.
Timescale, yeah.
Just for the past 24 hours.
Last 24 hours.
24 hours.
Yeah.
The reason I was asking the question was, imagine that you suddenly decide that you've spotted something that you had created a new piece of analytics for, and you thought, we better go back and analyze the last 6 months' data, because that would give us more trend information. You could do that, I guess, because you're keeping it all.
Yeah.
So that's
Sure. And because we have all of the customers' property files, we could catch anomalies, and we could say to the customer, some of the thread value that you have set in your cluster could be increased so that your S3 puts could be a little bit faster than it is right now. So that's the kind of analytics that we are running on.
Okay.
And I think there's also a common goodness that comes out of here, right? So I think one of the use cases that we are actively working on is, so let's say you have found an anomaly actually, or a bug in one customer because it hit it over there, right? So we can actually also start analyzing other customers' data to see if there is a probability that somebody else is going to hit it, right? So I want to call the guy and tell him that we have already seen a bug, and here is a patch for it, and I think you should upgrade on it because of your pattern. Again, so collecting all that information, letting the machines run at a faster rate and analyze all that data makes us smart, right? So So I think that's all I had, especially around like all the different areas how you do smart operations. So I'll open it up for questions. Like if you guys have. Did I go too fast?
So just going back into kind of, do a wrap up, because we've gone through the kind of main topics, just in quick summary. You saw smart operations here from Vikram as we try to scale systems, because we know how to build petabyte scale systems, but it's not just about building petabyte scale systems. It's about let's build systems that are easy to manage and operate. Let's build them so that not just you're the only one managing it, but we take some ownership of that as well, which is what smart support is all about, so that we can automate that. And then thirdly, how can we actually bring analytics into the platform too? The nice thing about objects is they have a lot of metadata, a lot of information. How can we actually leverage that richness of the object and actually make systems that honestly won't look like storage systems anymore? They will look like data systems. They'll look like things that you can get information out of. They're not things that are a whole bunch of drives and we'll think physical anymore. We'll think of the value I can get from a storage system, the type of data, the type of analysis we can get. And we think that's why we call this smart data storage. We really think it's about a different type of, it's about smart data. It's not so much about storage, it's about smart data. And let's work out how we make storage systems smarter, but how do we make the data more accessible, more usable, more consumable by customers? Yeah, question.
How many customers do you have? Average size of the cluster? And
So great question. We're actually over 65 customers, and we're, I haven't looked at the latest numbers, but that was the end of last quarter. We've actually been growing very well as a company. We're about 80 people overall in the company and growing substantially. Average size of the cluster actually ranges all over the place. I actually don't have the average. We've got some customers that are 10 to 15 petabytes. And then we've other customers that are down in the couple of hundred terabytes. So it actually ranges. It's quite a breadth of customer range. What we're seeing is more and more high-end customers. We're seeing much more of the scale customers. And that drove most of, we just did 6.0 only a couple of weeks ago in terms of our release. In fact, we actually just closed it this week. Was it GA this week? That drove most of the requirements. Honestly, the big customers drove most of the requirements into 6.0. It's why we looked at smart operations. It's why we looked at all of the automation stuff and the durability stuff that you put in. It's why we looked at things that are, the really boring stuff, as Vikram said, being able to actually point out which drive has failed so that when you've got a rack of equipment in there and your eyes go all googly-eyed, that you can actually go and grab a drive and replace it, and you've grabbed the right one. So all of that was built on because we're hitting scale and we're hitting it, across all of our customers. And you saw what Mike had in terms of growth overall.